In this video, we're going to look at a slightly more awkward case of using linear interpolation to estimate the median. Have a look at this. In this example, here's the question. In a shopping survey, a random sample of 140 teenagers were asked how many hours to the nearest hour they spent shopping in the last month. The results are summarized in the table below. Well, we need to use linear interpolation to estimate the median, but the awkward thing is they've given their answers and they've been rounded to the nearest hour, which means they took their original data, which was continuous because it was time. It could have been 4.3 hours, it could have been 6 hours and 1 minute, and they rounded to the nearest hour. And so the edges of our classes don't match up. This is 0 to 5, and then there's this gap 6 to 7, and there's a gap 8 to 10. So what we need to do in these kind of situations is we need to think, what are the actual class boundaries? Well, certainly the smallest amount of time they could have spent is 0. But what's the biggest amount of time that could have still been in this column? Well, it's anything up to 5.5. So 5.5 is really the edge of that boundary. And the smallest thing that could have ended up in this class is 5.5. And the biggest thing is 7.5. So what we're doing here is we're actually writing down what are the real class boundaries. And what I mean by real class boundaries is that we're going to think, what would they have been if they hadn't rounded them to the nearest hour? So anyone who got more than 15.5 ended up in this group, and anything up to 25.5. And this is going to be essential for getting accurate answers here. Okay, once all of that is in, and really what you should do is always begin a question like this by checking to see if the edges match up. If they don't, as they don't here, then just put in all of these 0.5s or whatever you need to do to fill in that gap. All right, now we're in a position to use interpolation. So it's 104 teenagers and we want the median. So we're going to do 104 divided by 2. No need to do the 104 plus 1 if we're working with group data. So we're looking for the 52nd student. And how can we find them? Well, we're going to keep track of our cumulative frequency to see which class they're in. So we've got 20 students so far up to this point. Chuck in these 16, that takes us up to 36. Add in the next 18, and that's going to take me up to 54. And at this point, I know I must have passed the 52nd student because I'm up to 54 students. And it happened in this group, so I know that this is my class in which the 52nd student appeared. Now, how far into that group? Well, we had up to 36 before, so how many more students do I need to go into this group before I get the 52nd? Well, it's 52 minus 36 is 18. So it's the 18th student. Sorry, that's not right. It's 16. 52 minus 36 is 16. So it's the 16th student in this group. Okay, the reason is if I've got 36 here and I add in an extra 16 from here, that will get me up to the 52nd student. So now I can say what fraction of the way into the group this is. The fraction of the way into the group is 16 over 18. And I want to go that fraction of the way into this group. Now, this is why the edges of the group really matter, because what's the class width here? It's not 8 to 10, it's not 2, it's really 7.5 to 10.5. So it's really 3 that I need to multiply by, and then I need to add on to the lower bound, which is actually 7.5. So this is the calculation I do. 16/18 tells me the fraction of the way into the group to go. The group has a width of 3, and I go that far in, so I start at 7.5 and move that far into the group. And that takes me to 10.17. So 10.17 is an estimate of the median, so that's given in hours. So there's a linear interpolation used in a case where the edges of your boundaries don't quite match up.